Castle or their or his affiliates are not responsible for followers' use of the information provided here. Hi everyone, Stephen Van Tassel here, wildlife control consultant, bringing another episode of Living the Wildlife as part of the Pest Geek podcast family. Glad to have you on board. I hope your week went well. I'm recording here today on Columbus Day. Have the day off, so I'm able to do a little bit of work. I've been doing a fair amount of traveling, and so getting a little behind on getting some of my podcasts out. So my kitty is shrinking down, and so I'm needing to make sure I get some of these podcasts out. Do take a few moments, if you would, and subscribe to the channel, and of course ring the bell. And if you could give us a 5-star review, that would be most appreciated. You can also reach out to me at wildlifecontrolconsultant@gmail.com, wildlifecontrolconsultant@gmail.com. Would love to hear from you. You can give me ideas for shows, perhaps a topic you'd like to have covered. Perhaps you'd like to be on the show, discuss your product or service, perhaps a technique or an issue that you have with the industry. Would love to have you reach out to me. Also, if you want to visit us on Rumble, we also post our podcast over on Rumble for those of you that don't want to deal with YouTube. So nevertheless, we're glad you're here, whether you're watching us on YouTube or whether you're watching us on Rumble. Glad to have you here. So this week, wanted to talk about deer. I had to do some have to put together some presentation on deer for a training I have to give soon. So I'm figuring, well, let me do a little drill down on deer. I'm not going to talk about everything about deer. I think I've had a previous podcast on some of the repellent issues, but today I wanted to talk about frightening devices with deer. So let me get my PowerPoint up and get that started up here. Bear with me here as I'm getting this done. All right, well, there we are. So before we kind of get into frightening devices in deer, I want to just simply survey again the types of frightening devices. So you may or may not be familiar with this categorization, but frightening devices, of course, are non-chemical methods of scaring an animal away from an unwanted area. Okay, and it's important, that's why we call them devices, because they're not typically going to be regulated by the Environmental Protection Agency. And so the goal is not to capture, the goal is not to harm, the goal is simply to create a scenario that causes the animal to say, this scares me, I need to get out of here, and then leave the sensitive area where you don't want the animal to be. So these frightening devices fall into one of 4 categories. We categorize them in 4 different ways. And it's important for you as professionals, or if you're a non-professional listening in, we're welcome. We're glad to have you. But understand the types of devices that are out there, and they all fall into these 4 main categories. And the reason why this is important, because if you find that a certain audible frightening device doesn't work, well, then you have to ask the question, do you need to try a visual one? And if you tried a visual one, did you try an audio-visual one, or did you try a biological one? So an audible frightening device, of course, uses sound. There has to be some sort of a noise related to it. You'll often hear things such as, could be a loud bang, or a propane cannon will be used to frighten animals. It's just a loud boom. Some people will use firearms, that just shooting a gun off sometimes frightens an animal away because they don't know what it is. That's audible. Visual, of course, relies on sight. Some sort of irritating visual thing. One product in the market uses a strobe, for example. And so I'm talking about frightening devices across all animals here, not just simply deer. Okay, we're just talking about the category of control method called frightening devices. So visual products, mylar tape would be another example of a visual frightening device. A sun hits it, it flashes, and that can scare like woodpeckers away from your house. Another category is audio-visual, so it puts both of the audible and visual components together. Pyrotechnics is the classic example of an audio-visual encounter. So you can shoot these off, they scream through the air and then let off a big boom, and you put that in proximity to whether it be a deer herd or Canada geese or other types of birds, there's going to be a flight response to that. That's just very, very powerful. And then the last one is a biological frightening device. And what this relies on is something that's innate in the animal itself. For example, Dr. Scott Hingstrom developed a product where it uses the alert call of a deer as well as the distress call of a deer to frighten them away. So it first has an alert call, like a which is an alert, and then it uses the distress call to tell the deer something bad is happening to one of your compatriots and you need to go because you might be next. So that tries to key into something almost at the genetic level of an animal, because these sounds are hardwired in to the animal, and that's more of a biological. Perhaps you could look at some of the hawk sounds that you may hear for bird frightening devices as part of that. Like when a hawk screeches, that would be something that a bird would be frightened of. And so that could be considered a biological frightening device rather than an audible. So there might be a little debate about that. But anyways, the categories are useful so that you can understand where a particular method fits when you're looking at different types of methodologies, like for frightening devices. Like, because if you use the visual, well, then is that really going to work in this situation, or do you really need to move to an audible or maybe an audio visual and that sort of thing? So we're going to talk today about a visual frightening device for deer. And one of the advantages of visual frightening devices over other types of frightening devices is that they're quiet. And this is something that really limits a lot of the frightening devices from wildlife control operators. You're just not going to be able to put a propane cannon in someone's backyard in an urbanized area. The neighbors are going to go nuts because the sound is so loud, people are going to be complaining about it. The same way with some of these, these bird distress calls, that the sound of the screeching and the constant noise can be irritating to those neighbors who are in proximity to that. Visual frightening devices don't have that problem. And they're directional, right? Because the light's only going to go in one direction. And if you can focus it in an area that's not going to bother neighbors, it's going to be both quiet and they're not going to even notice it. So that's one benefit, of course, of visual frightening devices. So we're going to talk about a specific visual frightening device for deer today. And that is lasers. So you may not have thought much about lasers for deer, but do they work? And so this is some research that was done on lasers back in the earlier part of this century, back 2000, I think 2003, 2006, if memory serves. But nevertheless, this was some research done, so we're going to talk a little about lasers and whether they're effective or not on frightening deer away from unwanted areas. But first, before we do all that, we have to discuss what exactly is a laser. Well, a laser is, I'll read this for those of you who are driving, a light amplification by stimulated emission of radiation. So laser is actually an acronym. Light amplification by stimulated emission of radiation. It was first developed by a man named Theodore Maiman in 1960. And so the reason lasers work, or what makes a laser, is that it employs coherent light, so light that's not scattering, and allows this light to be concentrated into a tight beam. If you ever turn on a flashlight, for example, you know that the light is immediately dispersing away from the flashlight. Well, with lasers, it's concentrated, and it's really a fine beam, and so it can it can go long distances before it begins to spread out. Where try that with your flashlight. It's dispersing over a wide area relatively quickly. And so there's some interesting things that go on with lasers, to be sure. So it would be a way of being able to, if they work, to be able to target specific deer if you needed that deer to move, if you could frighten deer with it, because you could target a specific deer. Now, we know that lasers work on Canada geese, for example. They will frighten flocks of Canada geese. So we know they work on other species. Sometimes people will use lasers inside of big box stores when there's a bird that's just not moving properly, where they can get a good shot at it, provided shooting is legal in your area in that situation, or trying to get that bird to frighten into a mist net, for example. That would be an example of the laser frightening that animal from a particular location. So does this work on deer? Well, we're going to take a look at that here shortly. Lasers come in various classifications, and this is important because lasers are potentially dangerous. Whenever you have concentrated light beams, that could be damaging to people's eyes. In fact, you've probably seen the movies in where lasers are used to cut through things and start fires. So lasers can be dangerous, and so you have to be careful with them, right? So we have various classes, and let me just kind of go over them relatively quickly here. This is a very ugly slide, but it's important information as professionals, if you ever get involved in laser work, to make sure you have a general idea of what the numbers mean. So as a rule of thumb, the larger the number, or the larger the class, the more dangerous or powerful the laser is. So a class 1 is the lowest level of laser. Think of it as a little pointer that you may use in a classroom or something, and it's basically safe. Actually, no, that would be a level 2, I think, a class 2. But it's eye safe under all operating conditions. So your laser printer would be an example of this, right? So it uses a laser, but it's not, no one's going to get blinded by it. And so it's generally safe for the naked eye. Class 1M is generally safe for the naked eye, but could be hazardous if you looked at it through a magnifying glass. Okay. Now, a class 2 laser is anywhere from between a 400 and 700 nanometers. That's sort of a measurement of the wavelength of the beam. Assume that natural aversion response prevents eye damage. So yeah, now we're starting to get into something a little bit more powerful. And it's assumed that you're going to feel pain if someone shined it in your eye. You're going to move your eye away because it hurts. Like if you ever had, someone blind you with a flashlight, right? You immediately turn your eyes away because it hurts. But if you happen to power through and just stare at that laser for an extended period of time as it's shining into your eye, well, then there could be damage done to your eye. Class 2M can also be hazardous with the aid of magnification equipment. Nothing really, why wouldn't it be, right? So that's sort of weird. There's a next class, Class 3R. In this class replaces what was formerly known as Class 3A. Now at this level, the lasers can produce 5 times the emissions of Class 1 or Class 2 lasers. So we're talking orders of magnitude more powerful than the previous lasers we've spoken of. Now, Class 3B lasers have an intensity that the max permissive exposure, and you're going to see that acronym of MPE, max permissive exposure, may be exceeded, and direct viewing of the beam is potentially serious. Now, this particular classification, Class 3B, has limitations on the wattage, on how much wattage can be in the laser. Now, the highest class, or what I'm going to say is the most dangerous class of laser, is a Class 4. This class is hazardous to view at all times and may cause devastating and permanent eye damage, and it may even ignite materials. It's so powerful that even if you reflected the light off of a surface, that reflection light could be damaging to your eyes. So very, very serious. I don't think there would ever be a need as a frightening device for us ever to be using a class 4. So we're always going to be looking at either using a class 2 or probably a class 3 laser. Class 4 is, I just trying to imagine a need to use a class 4 laser in wildlife control. Maybe there would be a situation, but it wouldn't be used, to my mind, as a frightening device. It may be used as a lethal device, but probably not as a frightening device. Okay, so just basically take away, the higher the number, the more you have to be careful with it. Okay, and you should always be careful with lasers, but it's the difference between your child's toy gun and an actual gun, right? So that's what we want to think. We want to be careful with all of these things. So a couple of safety issues and legal issues you need to consider if you ever decide to use lasers, whether you're going to be using them for birds or anything else. This is just sort of a quick review. I'm not calling it comprehensive, but it's just sort of a reminder that whenever you're using lasers, never, 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 never point them at aircraft. That is a serious federal offense. And the federal government's getting a lot more careful and studious about chasing people down that shine aircraft. Okay, so you want to deal with the feds. That's one way to get federal attention in a hurry, and that is because it's extraordinarily dangerous to do that. It can interfere with the flight of the aircraft. Of course, it can blind the pilot. Pilots need their eyes. And, of course, it can threaten the people both in the air and on the ground. That is very, very serious. So always be cognizant where you're pointing that. As one thing I read once was never let the beam go above horizontal or parallel to the ground. Now, obviously, that's a pretty strict rule, but the idea is you're not shining it to the sky, right? So if you don't shine it to the sky, you're not going to hit an aircraft. Never point them at people, right? Because you always want to be considerate. You could be damaging someone's eyes. You don't know how good their vision is to begin with, and you may shine them, and all of a sudden you've caused additional damage to their eye and maybe led them to total blindness. You just want to don't do it. You don't need the liability. Don't do it, and never, of course, shine the lasers in your own eyes. Okay, so treat these products, treat it like a gun. It might be a good analogy. Watch where you're pointing it. Make sure you maintain muzzle control. For those of you that use firearms, be careful with your lasers. Okay. So the question now becomes, do lasers work? Well, this is some research done by Dr. Kurt Vercauteren. He is basically one of the world's most experts on deer. He works for the National Wildlife Research Center. So he's a federal employee, but he is world class. Okay, we're not talking about just someone who just got out of school here. This guy is world class. He was actually trained by my former boss, Dr. Scott Hingstrom. And so Vercauteren is the real deal. Okay, so he's done a lot of work. You do a search on his name. I'll spell it for those of you who are driving. It's VER, capital C, AUTEREN, Vercauteren. And he published an article with others. Of course, he's the primary author, but with others, in 2003. And it's entitled, "Red Lasers Are Ineffective for Dispersing Deer at Night." And that was published in the Wildlife Society Bulletin, Volume 31, Issue 1, pages 247 through 252. Now, I'm not going to read the entire article for you, so don't worry about that. We're going to summarize it here. But let's talk about what he did. They basically studied two different types of red lasers. The first one was the Desmond model FLR005, and it gave out a laser that was 633 nanometers in wavelength. It's a 12-volt battery-powered helium neon laser configured as a rifle with a 3 to 9 power scope. Its class is a 3B now, so that's a serious laser, okay, with a power of 5 MW. It's not megawatts, but it must be 1,000 watts. And fixed beam diameter of 12 millimeters out to 2.5 kilometers. The laser was originally designed to frighten birds. And so they basically took this off-the-shelf product and said, hey, will this work on deer? Let's find out. The other product that they used was called the Dissuader Physical Security Device, and that used a wavelength of 650 nanometers. And it used 4 AA batteries, and it used a diode laser configured as a flashlight. And it had the ability to, had a focusing ring that could manually change the size of the spot at any distance. It was a class 2, so a little bit less powerful, with a power rating of 68 MW, effective up to 500 meters at night. And this particular device was marketed as a threat deterrent product for security personnel, probably something to frighten people or get them to dissuade or disperse from a particular area. So these are the 2 lasers that they use. So these are not your, laser pointers that you use in the classroom or shine at your PowerPoint, right? These are serious products. And basically what they were doing is they were studying deer inside of agricultural fields, and they would monitor whether the deer, when they shined the control, which was a spotlight, or the laser at them, to determine whether or not the deer would run away. They had 177 total encounters across both lasers. And what they found was there was no difference in flight response by the deer between lasers or between the lasers and the control, which was a spotlight. In other words, there was no difference in effect. It was as if it didn't matter whether you shine the deer with a spotlight or shine the deer with a laser. The deer behavior was identical between items. They also found that there was no difference in the size of the deer herd. So let's say they had a lot of deer and they were shining the deer. It didn't matter whether it was a lot of deer or a little deer. They didn't respond any differently. Now, what the authors did think was, or wonder, I should say, was whether the deer would act differently in an area where they had the ability to run to cover. For example, if they were in a wooded area as opposed to an open agricultural field area. It's sort of like the theory would be you're less likely to run if you have nowhere to run to. So why run? But if you're in the woods and you were frightened, well, you could run and hide because the trees would give you a sense of cover and you could find places where you could no longer be seen by the threat. Don't know, but that was a question that they asked, and I figured I'd throw that out to you. So one of the things that the authors were talking about is, can deer even see red? Well, they pointed out that deer vision has basically 3 components to it in terms of the cones. And they found that in these cones, because they're dealing with deer at night, so cones, and you have rods and cones, they're going to focus on these three parts of their vision because they weren't shining deer during daytime. So they found that deer have one set of cones that deals with the blue color, and that's 450 to 460 nanometers. Deer also had another part of their vision with the cones that dealt with 537 and 500 to 542 nanometers, which was yellow-green. And then they had another set of cones that could see at the peak. In other words, the highest nanometers was 497, which is in the blue-green range. So the point would be is that at night, deer can see blue, they can see blue-green, yellow-green, but it didn't seem that deer had the ability to see red. Excuse me. So maybe the exercise overall was kind of useless, right, in that regard, because maybe they can't perceive red at all. And of course, they're using a lot of wiggle room here because how do you know what's going through the deer's head, right? So, but as far as we know, at this point, it doesn't seem that deer can perceive the color red. So therefore, the red laser would have meant nothing to them. They couldn't see it, almost like they were colorblind to it. So that obviously raises the question, well, if they can see blue and they can see blue-green and yellow-green, what happens if we try blue and green lasers? And so guess what? In 2006, that's exactly what they published. And the article of this, of course, very similar to the previous one and published in 2003. It's by Dr. Verkoteren et al., 2006. Green and blue lasers are ineffective for dispersing deer at night. I forgot my T there. Wildlife Society Bulletin 34, Volume 34, Issue 2, pages 371 to 374. So as before, they had some lasers that they were testing. Here are the lasers that they were testing. The first one was from C-Tech. I don't believe these types of lasers were generally available on the retail side of things. Certainly the first one they mentioned was made specifically for them, and that was the C-Tech green laser. 534 nanometers, 120 MWs, 64 had a beam of 64 centimeters in width at 100 meters. So not a very tight beam there, to be sure. The next two lasers were blue lasers, and they were produced by Power Technology. The first one was Power Technology. That's a 5 MW blue laser, and the Melis Griot laser, an electronics group laser of 15 MW. So you can see some differences there in the wattage. Both blue lasers had beams that were 41 centimeters and 13 centimeters respectively in spread at 100 meters. So certainly not as tight as the red lasers, but nevertheless something that gave them something to test. So what were the results of using these lasers? Out of 307 encounters, summing up their use of all three lasers, they only had 13 flight responses occurred. So out of testing this 307 times across the three lasers, so when they summed up all of their use of these three lasers, total was 307 tests, because each, obviously, shining it at each group of deer is one test. Did it 307 times, only 13 times did the deer run away. That's pretty low, if you ask me. They pointed out in the article that they believed the deer could perceive the lasers because they saw the deer watching the laser. They saw them watching the beam. But they said they thought the deer were more curious about the beam than frightened by the beam. They also found, as before, there was no difference in flight response between the treatments. In other words, there was no difference in flight response between the blue and the green lasers, or between the blue and green lasers and the control. And they also found no difference in flight response based on the size of the herd that they tested. So if there was a couple of deer, the response was the same as if there were 10 deer. No difference whatsoever. And you can see here that I cut out basically their table pointing out their use of the green laser with the control and the blue laser and the 15 MW blue lasers, and it shows you their control, the treatment, control, treatment, all the way down the list, and you can see the numbers are pretty pitiful in terms of how effective they were. I think the highest number I see here is 14.0%. Clearly not something which was a six groups ran away out of 43 tries, which is absolutely dismal. So what that means is if you're going to go out and try this on your own, you may find a deer run away from it, but then you have to ask the question, was it really the laser that did it, or was it you that did it, right? Were they afraid of you? Are you too close to hunting season? Are you too close to deer? But at this point, it doesn't appear that red, that deer can't even see the red, it looks like. And on the blue and green lasers, yeah, they can see them, but it doesn't seem to be effective in getting them to disperse at night. Now, does that mean that a more powerful laser down the road wouldn't work? I don't know. I mean, this is how this goes, right? But it doesn't look promising. So as far as lasers are concerned, it may be a dead end. However, wildlife control operators are a creative and clever group of people that are always tweaking with things. And, one of you may come up with something that works. Who knows? But definitely keep your skeptical ears up when it comes to buying these things. If you are buying any of them, make sure you know what the return policy is, so that if it doesn't work in your situation, that you can return it. And if it does work, hey, I would love to hear from you, because I think that, this is just one study. It's a very powerful study, but maybe it will work in a different context. Maybe you're going to try it in a more wooded area, or an area maybe what's more urban, or who knows, maybe there's a different context when lasers would work. And I think it would be great to learn if you had success or failure with those types of things. Well, that's basically it for me today. I'm Stephen Van Tassel. You've been listening to Living the Wildlife as part of the Pest Geek podcast family. Would love to have you subscribe to the channel, of course. Join us on Facebook. Join us, the revolution, as Franklin calls it. You can join us on the Pest Geek podcast group on Facebook. We'd love to have you comment about your triumphs and trials and questions. We'd love to hear them. You can also reach out to me at wildlifecontrolconsultant@gmail.com. That's wildlifecontrolconsultant@gmail.com. Would love to hear from you, both thoughts about the show and future topics you'd like to have covered, or perhaps if you want to be on the show, definitely reach out to me. Would love to hear from you. You can also subscribe to my channel over on Rumble. Just go to Wildlife Control Consultant. You can subscribe to my channel there. Well, this is Living the Wildlife. It's part of the Pest Geek podcast. Why do we call it Living the Wildlife? Well, because we want you to live the wildlife, not be the wildlife. Take care, everybody.